Hi, I'm so glad that you could join me in this discussion on solving quadratic equations and the most advantageous method to use in solving them. So remember, when solving quadratic equations, we have the options of solving them by factoring if the expression is factorable, by completing the square, or by the quadratic formula. So let's look at this first one. Negative 2x squared plus 8x is equal to negative 10. Well, here I notice that every single one of the coefficients is evenly divisible by 2. And in fact, my lead coefficient, the coefficient in front of the x squared term, is a negative 2. So I want to divide both sides of this equation by negative 2 in order to get the coefficients to be a little bit more manageable to work with. So we'll start this one by dividing everything through by negative 2. So we're dividing both sides by negative 2, which means each term on both sides gets divided by negative 2. This gives me the equivalent equation x squared minus 4x is equal to 5. Now, in looking at that, it looks like it has a good possibility of being a factorable expression once I bring that constant over. So I'm going to see if this might be something I could solve by factoring. Now remember, to solve by factoring, I need to have a 0 on one side of the equal sign. So my next step here is going to be subtract 5 from both sides to get that 0 over there. So I have x squared minus 4x minus 5 is equal to 0. Now, I look to see if x squared minus 4x minus 5 is factorable. Well, my coefficient in front of my x squared term is a 1, so I'm really just looking at the factors, the numbers that multiply together to give me negative 5, but would add together to give me negative 4. And actually, positive 1 and negative 5 do that. So this actually does factor as x plus 1 times x minus 5. And then because it's equal to 0, and the reason we needed a 0 on the right-hand side, if a multiplication of two quantities equals 0, one of the quantities has to be 0. So I have x plus 1 has to be 0, or the x minus 5 has to be 0. And we can solve for x. Subtract 1 from both sides, I get x equals negative 1, or add 5 to both sides, x is equal to 5. So there's the solution of that first quadratic equation. So now let's look at the next one. X squared minus 10x minus 7 is equal to 0. Well, I've got that 0 on the right-hand side, so then I'm going to look to see if this could be solved by factoring. And I kind of look at it as, can it be solved by factoring? If not, can it be solved by the quadratic formula or completing the square? And I do factoring, completing the square, quadratic formula kind of is my mode of going through the thought process. But here, this quadratic equations in descending order, the coefficient in front of the x squared term is 1, but there are no numbers who multiply together to give you negative 7 and also add to give you negative 10. So that's not an expression that's factorable. So now I'm down to completing the square or the quadratic formula. But this one also has a lead coefficient of 1 and a coefficient in front of the x term that's even. When that's true, then completing the square is a good option. Now the thing with completing the square is that it does have a different start to it. With completing the square, you want the variable terms on one side, leave a space, and the constant, the number term, on the other side. So we're going to add 7 to both sides to write this as x squared minus 10x is equal to 7. Now we're ready to complete the square. We want to find the number that we can add to the trinomial so that it factors as two identical binomials. To do that, kind of on scratch, we take 1/2 the middle coefficient, the coefficient of the x term, which is negative 10. 1/2 of negative 10 is negative 5. And then we square that number, negative 5. And negative 5 squared is 25. So that is the number that we are going to add to both sides of the equation. So we have x squared minus 10x plus 25 is equal to 7 plus 25. Remember, you have to make sure that you keep that equation in balance. Now factor x squared minus 10x plus 25. Well, that factors as x minus 5, x minus 5. And it is always in the factorization, when you're completing the square, whatever 1/2 the middle coefficient was. So this part of that scratch calculation is always what goes in your factorization when you're completing the square and then factoring it. On the right hand side, 7 plus 25 is 32. And then since these are identical factors, we can write this as x minus 5 quantity squared is equal to 32. Now we will use the square root property, and we're going to take the square root of both sides, remembering the plus or minus. And the square root of a quantity squared is that quantity x minus 5 is equal to, and then I have plus or minus the square root of, and 32 I can write as 16 times 2, getting ready to simplify that square root. And this gives me x minus 5 is equal to plus or minus, well, the square root of 16 is 4, and that extra factor of 2 stays under. And then lastly, add 5 to both sides, I get x is equal to 5 plus or minus 4 times the square root of 2. And those two solutions are the solutions to that quadratic equation. So next up, our last quadratic equation is 5x squared is equal to 2x plus 2. Now let's bring the terms all on one side to again see if it factors. So we have 5x squared minus 2x minus 2 is equal to 0. And here my lead coefficient 5 times my last constant term negative 2 is a negative 10. And there are no factors of negative 10 that add to get that middle coefficient of negative 2. So that expression is not factorable over the integers. The lead coefficient is 5, so I really don't want to use the completing the square because I need a coefficient of 1 there, and by dividing by 5 I would just make messier numbers. So this one I want to solve by the quadratic formula. Now with the quadratic formula, again, the setup is that you need to have that 0 on that right hand side. So that's good that we have that. Once you get the 0 on one side, you can identify your a, b, and c. So a here is 5, b is negative 2, and c is negative 2. And quadratic formula says that if you have your quadratic equation ax squared plus bx plus c equals 0, you can find your values of x by the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So this gives me, just plugging in for the values, we are going to put in our value of negative 2 for b. We are going to put in the 5 where our a is sitting, and we are going to put in this constant negative 2 where the c is sitting. So we have the opposite of negative 2 plus or minus the square root of negative 2 squared minus 4 times 5 times negative 2 all over 2 times 5. So we have the solution now, we just need to simplify it. The opposite of negative 2 is 2 plus or minus the square root of negative 2 quantity squared is 4, and then I want to take this negative 4, the minus with the 4 as I multiply. So negative 4 times 5 is negative 20, negative 20 times negative 2 is a plus 40. And that's all over 10. Remember, you have to add those terms together before taking the square root. So I have 2 plus or minus the square root of 44 all over 10. And then 44 factors as 4 times 11, and the square root of 4 is a 2 comes out. So I have 2 plus or minus 2 times the square root of 11 all over 10. And then in simplifying this, I have 2 terms in the numerator. So I've got more than one term in the numerator. In order for any number to remove as a common factor with the denominator, it has to be a factor of the entire numerator. I do have this factor of 2 in both of those terms in the numerator. So we are going to factor out that factor of 2, leaving me with a 1 plus or minus the square root of 11 in the parentheses. And that's all over 10. And now remove the common factor of 2. And I get my solutions of this are x is equal to 1 plus or minus the square root of 11 all over 5. So here are examples of quadratic equations. The first one solved by factoring. The second one solved by completing the square. And the third one solved by the quadratic formula.